Algebra 2, welcome back, and welcome to the end of another week. So one more week left of the year, so let's finish it out. On Tuesday, we talked about geometric sequences and found the formula, which is listed up here. And on Wednesday, we talked about arithmetic sequences and found the formula, which is listed here. Now, this formula, I don't need you to memorize it, okay? Anytime you need it, it'll be provided. However, sometimes we have to decide, do I even need the formula? Should I use it? So today we're going to kind of look at when do I use the formula and when is it kind of unnecessary to use the formula. Okay, so this first problem says find the 14th term of the arithmetic sequence if the first term is 5 and the common difference is -3. So first, arithmetic sequence. So right from the start, we know we're dealing with this guy. Okay, we don't care about geometric for this problem. Now, anytime it asks for a term that's kind of way off in the future, for example, if it asks for like the third term, it's probably quicker just to find what the third term would be. But the 14th term, for us to find 14 terms, that's going to be a lot of places where we can make a mistake. It's also going to take a little longer, and then we're going to have to count them up and figure out, is this actually the 14th term? So anytime it's something that's like kind of out in the future, that's when we want to use this formula. So up here, we'll set it up. A to the n equals, now it has a to the 1 right here, which stands for that first term, which we know is 5. Okay, then plus the common difference, which in our case is -3. I put parentheses just because it was a negative. Okay, and then we're going to multiply that by n minus 1. And in our case, it's the 14th term, so 14 minus 1. Now, a sub 14 equals, we're going to have 5 plus, now 14 minus 1 is going to give us 13. 13 times -3 is -39. And then 5 plus -39, or our value of a to the 14th, will give us -34 as our answer. Okay, so now, that's how we did the first one. Because it asked for the 14th term kind of off in the future, that's when we want to use our formula. However, on this second problem here, it says find or give the first 4 terms of the geometric sequence for which a sub 1 equals 2 and r equals -3. So if you want to, you can plug those into this and use it to find a sub 1, a sub 2, a sub 3, and a sub 4. However, if we remember what a geometric sequence is, I think it'll be quicker. Don't worry about the formula. Let's just find it. Because the first term, a sub 1, they already gave it to us. It's right there, 2. Done. Already 25% done. Okay, a sub 2, remember, geometric is when it's multiplied. Okay, it's going to continue to multiply. So 2 times -3 gives us -6. Now, just to show you real quick, if you had wanted to, you could have plugged that in. It would have been 2 times -3 raised to the 2 minus 1. 2 minus 1 is just going to be 1. -3 to the 1 is -3 times 2, still -6. So when we plug it into the formula, we get the same answer. But that's more work, in my opinion, okay, than we need to do. Instead, if it's a geometric sequence, we know it's just multiplying by that common ratio, which in our case is r equals -3. So if we multiply it again, negative times negative becomes positive. 3 times 6 gives us 18. And then the final one, a sub 4, if we take that 18 times -3, we're going to get -54. All right. Now, let's scroll down here. These are the exact same 2 formulas. I just put them there so we could see them as we scroll down. And we got 2 more problems. Here it says find the 9th term for the following sequence. Now, once again, 9th term, it's kind of up to you. That one's close enough we could count them out, but it's kind of off in the future. However, in order to use a formula, we have to know what type of sequence this is. Is it arithmetic, geometric, or neither? So if we look from -2 to 4, 4 to -8, -8 to 16, hopefully you can tell we're multiplying by -2 and we'll do that. Negative 2 times negative 2 gives us 4, times negative 2 is negative 8, times negative 2 gives us 16. One clue, anytime it's switching from negative to positive, you know it's being multiplied by some sort of negative number. Okay, I guess that wouldn't always have to be true, but there's a pretty high chance. Okay, so with that being said, it's a geometric sum. So we can put a little, let me get the pencil, a G, and our R value equals negative 2. And in fact, our a sub 1 is also equal to negative 2, because that was the first term over here. So if we use this formula right there, we'll do a sub 9 equals negative 2 times, I'll put it in parentheses, negative 2 raised to the 9 minus 1. Now, 9 minus 1 is going to be 8. I don't expect you to know this, okay? You could do it, you could figure it out, but if you don't, that's totally fine. So we'll just go here, and we'll put our parentheses and do negative 2, and then we click this raised to the 8th. Okay, now we hit equals, and we get positive 256. Okay, and then our final thing we need to do is multiply that positive 256 times negative 2 from the front. Okay, so times negative 2, and our final answer then right here, negative 512. Oops, let me get the pencil. So a sub 9 equals negative 512. Okay, and then our final one here, once again, it tells us it's an arithmetic sequence right here. So we know we're going to use this formula if we use a formula. We're looking for the 16th term. So once again, we can write them all out if we want, but 16 is pretty far in the future. So I recommend using the formula. So they gave us the initial value, that a sub 1. They also gave us the common difference, or d equals 4. So a sub 16 equals negative 18 plus 4 times 16 minus 1. Okay, we know that 16 minus 1 will give us 15. 4 times 15 is going to be 60. So it'll be a sub 16 equals negative 18 plus 60. Okay, so all we have to do is add that together. And you can use your calculator if you want, that's fine. We'll get a sub 16 equals 42. Okay, so it's kind of up to you. If you want to play it safe, you can always use the formula. Sometimes it's going to be more work using the formula. However, if it's something in the future, it's probably a good idea to use that formula because it's going to save you some time. Now make sure if you're doing that, you have to establish, is it arithmetic or geometric? We can easily do that by looking at the pattern. Okay, so arithmetic is when it's adding or subtracting a consistent amount. Geometric is when it's getting multiplied. Okay, sometimes it looks like divided. So those are our two different types of sequences we have formulas for. And please let me know if you have any questions.